Here we have a SAT math problem. Okay, let's go to the question. Radioactive decay is an exponential function where the amount y of radioactive material is reduced by 1/2 over certain period of time t. The table above represents such exponential decay over 400 years. How much of this material in grams would remain radioactive after 1000 years? Okay, when I go over this data here, when t is equal to 100, that is in 100 years, the amount of material left is 400 grams. In 200 years, the amount of material is left 200 grams. In 300 years, the amount of material is left 100 grams. Okay, when I go over this data carefully, every 100 years, the amount of material is reduced by 1/2. So since the amount of material is getting reduced by 1/2 for every 100 years, the half lifetime of this radioactive material is just 100 years. Okay, first let's write an exponential function which represents a given situation. In general, when we have half lifetime of a material, we write the exponential function as y equals to a times 1 over 2 raised to the power of t over h. Okay, here I'm writing 1/2. This is a decay rate. Since the material is getting reduced by 1/2, I'm writing the decay rate over here as 1/2. Okay, now let's understand the other components of this function. Here y is the amount of material after t years. And this A is the initial amount of materials. That is, this is the amount of material when t equals to 0. That is initial time. And this H is the half lifetime of the material. In this case, the value of H is 100 because material is getting reduced by 1/2 for every 100 years. Okay, here I do not know the value of A. That is the initial amount of material. That is when t equals to 0. For that, we can consider that data we have over here. That is for 100 years, we have the material 400 grams. And in 200 years, we have the material 200 grams. Okay, so what should be the amount of material when t is equal to 0? Okay, here from 0 to 100, we have a time period of 100 years. Then what number should be over here so that it will be reduced by 1/2? So then the amount of material has to be over here as 800 grams. So that in this time period of 100 years, so this amount will be reduced by 1/2, then this 800 will become 400. Okay, here I got the value of A, that is 800 when t is equal to 0. Now we can plug in this 800 for A over here times 1 over 2 raised to the power of t over H is the half lifetime according to the data we have over here. So half lifetime is 100 because for every 100 years the amount of material is getting reduced by 1/2. Okay, here I got the exponential function which represents a given situation. Our aim is to find the amount of material in grams after 1000 years. That is, we have to find the value of this y when t is equal to 1000. Okay, now let me plug in. That is y equals to 800 times 1 over 2 raised to the power of, we can plug in 1000 for this t over here. 1000 divided by 100. Y equals to 800, and we can write this 1 over 2 as a 0.5. And when I divide this 1000 by 100, I am getting 10. We can evaluate the value of this one using calculator. When I do so, I am getting 0.78125. That is, the amount of material in grams would remain after 1000 years is 0.78125. We find this value in answer choice A. The correct answer choice for this question is A.